We're going to look at sample problem 7.5 to finish off. So it says here in the final reaction above, we're looking at two helium-3 nuclei colliding to produce a helium-4 nucleus and two helium-1 nuclei, or also known as two protons. So we're basically looking at this equation here. So it's probably a good idea at this point to write this down because this is what we're working with, that equation right there. Alright, so this is before fusion, this is after fusion. And we're going to look at the energy that's released going from this side of the equation to this side. So the first part of this says, find the difference between the binding energy of the helium-4 nucleus, which is, remember, on this side of the equation, and the sum of the binding energies of the two helium-3 nuclei. So we're not interested in the protons here because that's irrelevant. So we're going to look at the binding energy first of the helium-4 nucleus. Now we have a table here, it's super useful. So we can see the binding energy for the helium-4 nucleus is right there. Okay, and the two helium-3 nuclei, there's helium-3. So we find first of all, what is the sum of the binding energies of those two helium-3 nuclei? We just take this number and times it by 2. So that's the sum. And then we find the difference between these two binding energies. So we take the smaller one away from the bigger one and we get this difference in energy. So this is the energy that is released in the fusion reaction, 12.9 around about mega electron volts. Now if we just wanted energy we could stop there, but we're going to look at the equivalence of using E equals mc squared. So again we're going to look at this equation. We're going to look at the mass that we started with, which is two helium-3 elements, and then we're going to look at the mass of what we finished with, and that's going to include the protons this time because they do have mass, so the helium and the two protons. So we look at the mass. It's asking us what's the difference between the sum of masses of the helium-4 nucleus and the two protons and the starting mass before fusion of the two helium-3 nuclei. So first thing is mass before fusion. That's the left side of the equation. The two helium-3s, we have two lots of them. So this is what we find when we do that, two lots of those. The mass after fusion is one of these and two of these. So you can see one of those and two of the protons. And the total mass after fusion is here. You see that the total mass after fusion is a little bit less than what it was before fusion. So that means that we've had a difference, a loss of mass. This much is the mass difference. Now that's the end of part B. Part C says what's the energy equivalent of this mass difference in joules and mega electron volts. So again we use E equals mc squared. Now E is going to be in joules. E equals the mass difference, because this is going to be converted into energy. The mass we lost becomes energy. Okay, so mass difference times, so that's there, times the speed of light squared. We pop all that in the calculator and we get this answer, which is in joules. Okay, to find the energy equivalent in mega electron volts, remember we take that answer and we divide by how many mega electron volts there are per joule. So it's 1.602, 176 by 10 to the negative 13. So we take our joules answer, divide it by that, and then we find it's 12.859 roundabout mega electron volts, which is cool because that's what we found by looking at the binding energies. So both of these questions, if you notice, are pretty much the same, but it's really just using different tables and just keeping on track of what you're looking at. It's all about before and after. It's products, what you're starting with, and then products. And here it's what you started with, so before fusion, and what you finished with after fusion. In our other example, which was 7.4, we were looking at before fission and after fission. And it's about either finding the energy directly by using binding energy, or finding the energy by using mass difference and using the equation E equals mc squared, which is energy equals the mass times the speed of light squared.